It could be the beginning of a cosmic nightmare. Astronomers have just made a shocking discovery on a distant exoplanet. Light emissions are being detected from its dark side, where no light should exist. The data, gathered by one of the most advanced telescopes ever launched into space, reveals a mysterious glow that appears to be technological in nature. Could this be the first concrete evidence of life beyond Earth? Or worse, something completely unknown? While scientists remain publicly cautious, behind the scenes, some are already discussing the possibility that this could be the first authentic signal from an alien world. The strange light coming from the dark hemisphere of Proxima B has captured the attention of astronomers across the globe. Initially picked up by ground-based observatories, these faint signals were later examined more closely using the James Webb Space Telescope. These emissions, appearing in specific infrared and visible wavelengths, have repeated consistently, suggesting they originate from a stable, perhaps even artificial, source. The most perplexing part? They're coming from the side of the planet that never sees sunlight. In that eternal darkness, there's no reflected starlight, so where is this glow coming from? Even more mysterious are the signal's periodic fluctuations in intensity, which don't match any known natural astrophysical patterns. The implications of this discovery are profound, and potentially unsettling. We may be facing either an entirely new cosmic phenomenon, or something not of natural origin. The latter possibility is especially unsettling, as it raises the idea that intelligent life might exist in the darkness of Proxima B. The concept of beings living in total darkness and producing artificial light or advanced technologies taps into deep-rooted human fears. Culturally, we often associate life in complete darkness with something sinister or uncanny. On the other hand, there are more grounded explanations. The mysterious signal could be caused by thermal anomalies, such as volcanic activity or the effects of atmospheric gases. These gases might become ionized due to energetic particles from Proxima B's host star, possibly funneled to the planet's dark side through magnetic field leakage currents. Another potential explanation is airglow, a phenomenon where atmospheric gases emit photons. However, no typical spectral lines have been observed so far, making this scenario less likely. Currently, the focus is on identifying so-called technosignatures, evidence of light generated by technology. Scientists are trying to determine whether the illumination on Proxima B's night side might be artificial. Unlike natural sources, artificial light from cities or industrial activity would have a distinct emission profile. For example, it might display a non-thermal, discontinuous spectrum, such as those produced by LEDs, lasers, or other electrical sources. These technosignatures can be isolated using advanced spectroscopic techniques, and that's exactly what researchers are now pursuing. By carefully analyzing the spectral energy distribution in the infrared spectrum, they hope to solve the mystery of Proxima B's glow. Their key tool in this investigation is the MIRI instrument aboard the James Webb Space Telescope, JWST, a secret weapon in the search for artificial light beyond Earth. The project is still in the conceptual stage, but NASA officials have recently reaffirmed that funding has been secured for this groundbreaking space telescope, and development will proceed as planned. This next-generation telescope will feature highly sensitive coronagraphs designed to block starlight, allowing direct observation of planets located close to their stars, such as Proxima B. This capability will enable scientists to study planetary atmospheres, cloud patterns, and possible technosignatures. LUVOIR will be capable of detecting even minute traces of gases like ozone, methane, and chlorofluorocarbons, chemicals that could point to industrial activity. A major focus of the telescope will be a systematic survey of Earth-like planets within habitable zones, making it the most ambitious mission yet in the direct search for extraterrestrial life. Its scientific goals go far beyond what the James Webb Space Telescope can accomplish. So, could we soon get a clearer image of Proxima B than ever before, perhaps even surpassing what JWST has shown us? Absolutely. Technological progress never rests, and space exploration is entering a new golden era. And what about NASA's Habitable Exoplanet Observatory? If you thought LUVOIR was the end of the line in terms of superlative space missions, think again. Developed in parallel with LUVOIR, HABEX is another powerful telescope concept, but this one is specifically focused on finding and studying Earth-like exoplanets and assessing their potential habitability. Proxima Centauri b is estimated to have a mass about 1.17 times greater than that of Earth, placing it among the category of potentially Earth-like exoplanets. However, despite this similarity, there are some key differences between our planet and its closest known planetary neighbor. Current scientific models suggest that Proxima Centauri b is tidally locked, meaning one side of the planet always faces its host star, similar to how the Moon always shows the same face to Earth. If this is true, then one hemisphere of the planet would experience constant daylight, making it significantly warmer than the perpetually dark night side. Although Proxima Centauri, the host star, is much smaller than our Sun, the planet orbits extremely close to it. Specifically, the distance between Proxima Centauri b and its star is only about 0.0485 astronomical units, just a fraction of the Earth-Sun distance. 1 astronomical unit is the average distance from the Earth to the Sun, roughly 93 million miles. While Earth takes 365 days to complete an orbit around the Sun, Proxima Centauri b completes its orbit in less than 12 days, a dramatic difference highlighting the planet's close proximity to its star. Although it might be tempting to imagine this exoplanet as a blazing cosmic furnace, researchers believe that's unlikely. Based on the star's brightness, the planet's average distance from it, and an assumed albedo of 0, scientists estimate Proxima Centauri b's equilibrium temperature to be around -38 degrees Fahrenheit. But again, this is far from a definitive figure. If the planet possesses an atmosphere, the greenhouse effect could significantly raise its surface temperature. In fact, a simulation published in early 2017 suggested a fascinating possibility. Depending on its atmosphere and orbital details, Proxima Centauri b might support stable, liquid water. This is an exciting prospect, given that liquid water is widely viewed as a crucial ingredient for life as we know it. Because of this potential, Proxima Centauri b is often listed among the most promising candidates in the search for habitable worlds beyond our solar system. Let's now explore some of the other known exoplanets that might also support extraterrestrial life. Worlds with potential. A planet's habitability potential is often measured using the Earth Similarity Index, ESI. Earth, being our only known life-supporting planet, scores a perfect 1.0 on this scale. Other planets are compared against this benchmark. Proxima Centauri b scores a strong 0.87, placing it fifth among the top potentially habitable planets. Taking the top spot is Teegarden b, with an impressive ESI of 0.95. This planet orbits a red dwarf in the Aries constellation, located just 12.5 light-years from Earth. Observations have revealed 2 Earth-sized planets orbiting this star, both situated in the star's habitable zone. Due to its age, over 8 billion years, the red dwarf is considered relatively calm, which makes the surrounding planets even more suitable for life. In second place is TOI 700d, with an ESI of 0.93. Located roughly 593.7 trillion miles away, this exoplanet is about 20% larger than Earth and takes 37 days to orbit its red dwarf star. Kepler 1649c, with an ESI of 0.92, claims the third spot. Found in the constellation Cygnus, the Swan, this rocky world has a radius about 1.06 times that of Earth and appears to have Earth-like temperatures. However, its atmosphere remains a mystery. Finally, we have TRAPPIST 1d, located in the constellation Aquarius, scoring 0.91 on the ESI. Part of a system containing 7 planets, this world sits just outside its star's habitable zone. According to models, it likely experienced a runaway greenhouse effect, which could have caused its oceans to evaporate. Still, there's a chance that some water may have survived.